Okay, so in the first part of this video, we derive the formula for the total time taken in the journey, which we call the time of flight, and also the formula to uh, get the time it took the ball or whatever body under consideration to get from the point of projection, which is A, to the maximum height, which is B. So if you've not watched that, I'll put the link of that video in the description. So just click on more so you watch on that, watch the video, and then you come back. So today we're going to focus on the maximum height. So we want to calculate this maximum height. What's the highest, the maximum height a body projected can attain? So remember, I said that this we're going to be using strictly the formula that we had already derived for uniformly accelerated motion. So we're going to use this formula that final velocity squared is equal to initial velocity squared plus or minus 2gh, where this h is going to be the maximum height. All right, so let's now carefully understand what will be our final speed and what will be our initial speed. Remember, this v is the vertical component, so I'm just going to put it as vy squared uy squared plus or minus 2gh, which is the maximum height. Again, I'd just like to verify to clarify that why we are using the vertical component of the speed is because the horizontal component of the body is not affected by acceleration due to gravity. So it's the vertical component that is affected by gravity. So that's why we use that. So now recall that at the maximum height, which is b, the final velocity is equal to 0. So if you know this, then we can begin to solve. Let's use this formula to derive what the maximum height will be by making a sort of formula. So we know that the final speed is 0. So 0 squared is equal to the initial speed is u sine theta. Remember, uy is u sine theta. So u sine theta squared, that's what we have, plus or minus 2gh, which is the maximum height. So let's go ahead and plug in the values. So this will be equal to 0 squared is 0. U sine theta. Now, what is u sine theta? U sine theta is 50. All right, we recall u sine theta is 50. I've already solved that. How we got 50 again is the initial speed is 100 meter per second. Then theta is 30 degrees. That sine 30 is half. Half of 100 is 50. So u sine theta is 50. So just going to plug it into the equation. We have 50 squared. Now we're going to use negative because the ball is going up against gravity. So it's going to be minus 2 times acceleration due to gravity is 10. Then times the height. So we have 0 equal to 50 squared is 5 times 5 is 25. You just add to 0 minus 20h. So we just move 5 the other side. It becomes negative 2500 is equal to negative 20h. So divide both sides by minus 20. So these 20s are going to cancel and this negative sign is going to cancel. And then finally, we now have our maximum height, which is h mass, equal to, let these zeros cancel. So we have 250 over 2. 2 into itself is 1. 2 into 5 is 2, remainder 1. Into 10 is 5. So the maximum height is 125 meter. Now, again, I want to tell you, why did we use our final speed to be? Why did it equate our final speed as 0? Now, the reason is because of at the maximum height, I clarified this in the previous video. At the maximum height, the speed is 0 because it is at that point that the body loses all its initial speed and then it begins to change direction to fall back to the ground strictly with the speed of gravity. So that's why the final velocity is 0. So you see that without even knowing the formula for maximum height, the projectile formula for maximum height, we can get the answer. But then using this same principle, let's now derive the formula. So why I like solving this without the formula first is to help you understand. So just in case you forget the formula, you can always find your way around if only you understand that we are considering only the vertical component of the motion since it's the one under the influence of gravity. So let's derive the formula. Again, we're going to use the same thing, but just that we're going to not dealing on general cases. So we have Vy squared is equal to Uy squared plus or minus 2gh. I just use capital since that's the maximum height. Again, that Vy at the maximum height is 0. So 0 squared. Now Uy, we are going to just leave it as U sine theta, all squared. Minus now because the boy is going against gravity. 2, sorry, I would have written 2 first. 2gh, which is the maximum height. So now let's distribute. So 0 squared is still 0. U sine theta, let's distribute the square. We have U squared sine squared theta. Now, why we write this as sine squared theta? Because we would have said that it would be, sine theta squared will now be, you now put the square here. Now, why we don't do this? Because of if you put the square here, you might be tempted to square the angle. So assuming we have sine 30, you will now square the angle. So 30 squared is 900. You now have sine 900, which is wrong. So that's why we like to write it like this, sine squared theta. So you can remember that it is not the angle that is being squared, it's actually the sine of the angle. So everything squared. So that's why we don't put the square on theta. Instead, we put it on sine just to help us to be safe and remember. So that's the reason for that. Okay, then minus 2gh. So move u squared sine squared theta the other side. It will now be negative u squared sine squared theta is equal to negative 2gh, which is the maximum height. So we just need to divide both sides by negative 2g to get h on its own. So we have negative 2g, negative 2g. Again, the negatives 2g are going to cancel and the negative signs will cancel this side. So we have the formula for our maximum height, h max, to be equal to u squared sine squared theta all over 2g. And this is just the formula you need. So this is the formula to get the maximum height of a body that is in projectile motion. So again, as our custom is to verify this formula and so let's see whether we get the same 125 meter. We're going to plug in the values and see what we get. So we have our maximum. I'm just going to solve it here again. We have our maximum height h max to be equal to u squared. Again, remember from the original question, u is 100 meter per second. So we're going to put u as 100. So we have 100 squared. That would be sine, not a signature. Sine squared theta is 30 degrees. Right, so okay, since you already have theta, I will show you how to write this so you can also type it like that in the calculator. So just write everything in the bracket. That would be better, I think. So write like this: 100 squared sine 30 all squared divided by 2g, which is 2 times 10. So let's just type everything in the calculator and we get the maximum height. Now doing everything, see we still have exactly 125 meter. So you see the formula makes everything short. So if you can remember the formula, because actually formula simply means shortcut. If you can remember the formula, it will be quite easy for you to solve and you solve at a faster pace. But understanding the concept makes it easy because as human beings is, in fact, what I discovered is that if you really understand the concept, then the formula would be difficult for you to forget because if you look at the formula, you can see the processes in the formula. So that's how I see it, all right? Because I now understand how to derive it and everything is so clear. So without the formula, you can still solve. With the formula, you solve even faster. So this is it for the maximum height attained by a body in projectile motion. So I just hope the concept is very clear to you. So stay tuned in for the next part of this video. We're now going to look at the formula to get the range, which is the horizontal distance the body covers in the journey. So thank you for joining. God bless you.